So we talked about natural log in our last video about being this area under the curve, and then we talked about the derivative of natural log and that the derivative of natural log equals 1 over x. So we found out in our last lesson that if I'm going to take the derivative of the natural log of x, that value is 1 over x. Well, today we are going to integrate. So if I integrate 1 over x dx, the area under that curve is going to equal the natural log of x plus c, because that's an indefinite integral. So that's the basic theorem. This integrating 1 over x uses lots of u substitution. So that's why it's good to learn u sub first, because if you don't know u sub, it's pretty hard to integrate with natural log. So let's try a couple examples. This one does not use u sub, this first example. If I want to integrate 2 over x dx, so I have a constant over x. What do you think that would equal? Well, 1 over x if I integrate is natural log of x, so 2 over x if I integrate would just be 2 natural log of x plus c. What you could do if you want to prove that, you move the 2 in front because it's a legal move because it's a coefficient. So 2 times the integral of 1 over x dx. We know that this piece is equal to natural log, so it'd be 2 times that. That's about the only type that doesn't require u substitution. So let's look at one that would require u substitution. I'm going to integrate from just indefinite, sorry. Let's do 1 over 4x minus 1 dx. So I look at this and I know that this is a rational function. How do I know this is rational? Because it's a fraction and it's got a function in the denominator. And so rational functions are going to their inverse, or their area, not their inverse, their area is going to be natural log. So in this one, I could let u equal 4x minus 1. Therefore, du would equal 4 dx. I don't have a 4 in my numerator, so I'm going to just divide. So dx is going to equal to du over 4. So then I can rewrite this as 1/4 from this 4 in the denominator there. 1 over u du, which would be 1/4. The antiderivative of 1 over u would be the natural log of u plus c. And then substitute that u back in to put it in terms of x. 1/4 natural log, technically of the absolute value of 4x minus 1, because the natural log cannot be negative. If you forget your absolute values, I care, but I'm not going to count it off. So that's a u substitution. Your u substitution, you could have one that was, you could have, let's see, I'm trying to think of one that's a little bit harder. That's the same type of problem. So let's say if I have x over x squared plus 4 dx. So here I would let u equal the denominator because it looks more complicated anyway, and that's usually where we start with our u sub. Our du would equal 2x dx. I don't have a 2 for a coefficient, so du over 2 is equal to x dx. So if I rewrite this in terms of u, I'm going to have, looks like 1 over u du. And out here I'm going to have 1/2. So now the antiderivative of 1 over u, or integrate 1 over u, is the natural log of the absolute value of u plus c. Throw that u in terms of x back in there, x squared plus 4 plus c. How do I know if I'm right? Well, if you want to check this, take the derivative of this. The derivative would be 1/2 times 1 over x squared plus 4 times the derivative of the baby inside, which would be 2x. Those 2 cancels. So I get x over x squared plus 4. So I was right. So that's how you can check those. Let's try some other ones, some different types of substitution. So this one you would see on any calc test. Like if you're taking a placement test or a final in calculus, this problem right here is a classic old natural log problem. Because we look at it and students get confused on what u should equal. Because I always say, well, it's the most complicated part. Well, the whole denominator is complicated, but we can't let it equal the whole denominator because the derivative of that. I could use the chain or the product rule, but that's still not going to work. So what you have to think about is you're looking for patterns. Which part of this function is a derivative of the other? Well, I know that I'm going to let this equal natural log of x so that I can show you. So my u is equal to the natural log of x. That means my du would equal, from the previous lesson, the derivative of the natural log of x is 1 over x dx. How does that help me? Well, this is my u. It's going to go there. 1 over x dx is right there. So now I can rewrite this as just 1 over u du. So then the antiderivative would be the natural log of u, absolute value, plus c. So I get the natural log of the natural log of x plus c. Crazy. I can't remember if we did a derivative one like that, but it's like a double chain rule, kind of. So it's a chain rule problem, like an inside, this is the inside function, this is the outside function. Some other ones that you might see are some trig ratios. So let's say the tangent of x dx. We don't have a rule for this one. Well, you might have a rule for it. I can't remember if we did that or not. But now that I know the natural log, what I can do is I have to remember, my hands are fat and touching the screen there, that the tangent is the sine of x over the cosine of x dx. So if that is my problem, what do you think I could let u equal? So we talk about it's the most complicated thing, and sometimes we just let it equal the denominator. So u is going to be equal to the cosine of x. Du, what is the derivative of cosine? So the derivative of cosine is negative sine of x dx, which works kind of. We'll have to move that negative. See, this one does not have the negative, so negative du would equal sine of x dx. So I get negative, I'm going to integrate from, it looks like 1 over u du. So I get negative the natural log of the absolute value of u plus c. Put my function in terms of x, so I get negative the natural log of the cosine of x plus c. And I believe, I can't remember if we went through on your, like one of those last days, if that was written on that doodle notes, one of those last days we actually had in class, if that was written on the doodle notes or not. But so you could do that with tangent, you could do that with cotangent, technically you could do that with secant, because secant is 1 over cosine, so you could kind of get that one to work. That one's a little harder. Tangent and cotangent are easier. Let's see, what else? Oh, these are all indefinite. So what if I make it definite? So now I'm talking about an area, like one of the ones I can check on Desmos. So when I have an A and a B, these are definite. So they are an area. So let's say I have this. It's rational. I can tell it's a rational function, so I'm going to let u equal the denominator. My derivative of that would be 3 dx. It doesn't quite work, so I'm going to put du over 3 equals dx. So when I rewrite it, I'm going to bring this 5 out front because it's a coefficient. So 5/3, 1 over u du. And remember, this part's that special part of u substitution. I'm changing my function to terms of u. That means I need to change my a and b. So I would put 0 in here. So 3 times 0 plus 1 is 1. And I put 4 in here. So that is 13. And then I integrate. So 5/3 times the natural log of u from 13 to 1. I don't have to turn it back in terms of x because I already changed my a and b value, so I don't need to do that. So I'd get 5/3 times the natural log of 13 minus the natural log of 1. Bonus points. Who knows what the natural log of 1 is? It's 0. So this is my answer. Again, you can get a decimal approximation, but that's what your answer would be. Let's try one more. This one's kind of a funky U sub one. Let's go 1 to e. That's right, e's a number, of 1 plus the natural log of x squared over x dx. So looking at this, it's definitely complicated. I definitely need a U sub. The most complicated part is inside that parenthesis. It's not the denominator this time, so let's let u equal 1 plus the natural log of x. And now I have to take the derivative. Well, the derivative of 1 is 0. The derivative of the natural log of x is 1 over x dx. Seems to work. I say that because you see this x is in the denominator right here. This part is the same as this. So that's good. So then I'm going to rewrite. I'm going to have u squared du. I need to change my a and b. So if I put 1 in there, 1 plus the natural log of 1 is just 1. And if I put e in there, 1 plus the natural log of e, and you can use your calculator to do this, or that comes out to just 2. And then I'm going to integrate. That would be u cubed. So I'm u cubed over 3 from 2 to 1. So it's 8/3 minus 1/3, which is 7/3. You can check those on Desmos, but I'm pretty sure they're right. And that's it. So you're going to work with some integrating of natural log. You're going to do a lot of u substitution.